All right, we are going to wrap up these last two, 15 and 16. And again, we are graphing these using a parent table and then a transformed table. So several different pieces of information we need to know getting into this. First, this only works with vertex form. So from vertex form, we can list the transformations. Our first transformation is that our graph or our parabola moves right 3. Our second transformation is that there is a x-axis reflection or a flip. That negative sign flips the whole parent function over. Our third transformation is a vertical stretch of 2. And our final transformation is that it is moving up 1. So with the exception of our blue is happening to our x value. Everything else is happening to our y value. So our blue affects our graph moving left and right. Steps 2, 3, and 4 affect our graph on the y-axis, or moving up and down. So when we do our parent table, we start with our standard parent table, -2, -1, 0, 1, and 2. And we have 4, 1, 0, 1, 4. Our parent table always has the same values. We use these 5 values. I mean, we could build out as big as we want, but 5 values are usually enough. So our transform table, our first step, like we just discussed, is affecting the x, and it's moving right 3. So we're saying x plus 3. Steps 2, 3, and 4 are all affecting the y. And so an easy way to do this is to look up here, and we can replace our parentheses with a y. So -2 times y plus 1. We have our flip. We have our stretch of 2. And we have our up 1. Okay. So once we've done this, we take our parent values. For our x is -2, -1, 0, 1, and 2. For our y, it's 4, 1, 0, 1, and 4. And these all correspond with each other. So these all correspond with one another. Okay, and then I'm going to use red here. We are changing our parent in our x values by adding 3. We are changing the parent of our y values by multiplying a -2 and then adding 1. And I'm going to write all my answers in, purple. So now we're evaluating each individual problem. So a -2 plus 3 negative 1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3. That side's not so bad. On our other side, we follow order of operations, so we're going to multiply first and then add 1 to that value. So I'm going to multiply negative 2 times 4 to get negative 8, plus 1 will give us negative 7. Negative 2 times 1 will give us negative 2, plus 1 will give us a negative 1. Negative 2 times 0 is 0, plus 1 is 1. And if you notice, this here is the same as this here. So if I got a negative 1 up there, I'm going to get a negative 1 down here. And same thing here. Okay. I'm going to go ahead and list those points so that I can see them a little bit more clearly. I have 1 comma negative 7. I have 2 and negative 1. I have 3 and 1. I have 4 and negative 1. I have 5 and negative 7. So all that's left to do is plot these. I can go 1, negative 7 and put a point here. I'll go 2, negative 1 and put a point here. I can go 3, positive 1 and put a point here. I can go 4, negative 1 and put a point here. And I can go 5, negative 7 and put my point there. And then I just draw in my parabola. Okay, wrapping up number 16. I'm going to start by listing my transformations again. I start on the inside and I do the opposite of that. So the first step is to move left 2. My second step is an x-axis reflection. Our whole parabola flips over the x-axis, so it is a flip. Step 3 is a vertical stretch of 2. So we're going to multiply our y value by 2. And then our last step is the whole thing moves, I already used blue. The whole thing moves up 4. And that's happening to our y value as well. So down below, just because there's a little bit more space to work down here, I'm going to have my parent table. And then I'm going to have my transform table. So step 1 is happening to x. It's moving left 2, which would be a minus 2. All of my other steps are happening to y. So I'm going to have a flip and a stretch, multiplying with y, and then we're moving that up 4. Okay, and here we go. Same thing. Negative 2, negative 1, 0, 1, and 2, 4. I put this one in parentheses because I know that it's multiplying. I could put the x values in parentheses as well. That one's just adding, so it's not really necessary. But my y value, I know it's going to be multiplying with this 2, and I use parentheses to show multiplying. So let's see here. I'm going to fill in the rest of this. We're subtracting 2 to every x value. we are multiplying a negative 2 and then adding 4 to every y value. And we just follow our sign rules. So signs are the same, we add them and keep the sign. And I'll use purple again. Signs are the same, add them and keep the sign. These ones, well, 0 minus 2 is negative 2. And then signs are different, subtract, keep the sign a larger number. So 2 minus 1 is 1, and the larger number is negative. And 2 minus 2 is 0. Don't have to worry about the sign for 0. Okay, and then on my other side, we're following the order of operations. We're going to multiply these first and then add 4 to it. So I'm going to be doing some mental math, but I'm following the same steps. In fact, this is our last one. I'm not going to do mental math. I'm going to work out 2 times 4, and then, so I'll work out the first step. Negative 2 times 4, negative 8. And that's still being added by 4. Negative 2 times 1, negative 2 plus 4. Negative 2 times 0, 0 plus 4. Negative 2 times 1, negative 2 plus 4. And negative 2 times 4, negative 8 plus 4. So all I did was I just worked out each one of these. I've been multiplying and then adding just in my head in one step, but this helps you see the steps. And now I'm just going to combine these. So negative 8 plus 4, signs are different. Subtract, 8 minus 4 is 4. Keep the sign a larger number. Negative 2 plus 4, signs are different. Subtract, 4 minus 2 is 2. And keep the sign a larger number, which is positive. 0 plus 4 is 4. And we have the same 2 problems here. So 2 and negative 4. So I'm going to write my ordered pairs, negative 4 comma 4. Oh, negative 4. I have negative 3 comma 2. Negative 2, 4. Negative 1, 2. And 0, negative 4. Okay. Before I plot these, we know that our graph, if this is the center point, our origin, our graph is going to be moved left 2 from there and up 4. So this is going to be the new center point of our graph. We also know that it's going to be flipped over, so it should be facing down. Oops. So it should be facing down like that. And we know it's going to be stretched too, so it's going to be kind of a longer looking, stretched out graph. If our normal graph, dang, keep using that eraser. If our normal graph kind of comes out like this, a stretched out one's going to be a little bit more narrow. So let's see what happens. Negative 4, 4. Oh, helps if I follow. Negative 4, negative 4. So negative 4, negative 4. I have negative 3, positive 2. Negative 2, positive 4. Negative 1, positive 2. And 0, negative 4. It is facing down. It moved, our vertex moved left 2 and up 4. It's facing down and it's stretched out. Okay, and that's it for graphing the transformation of a parent graph in order to graph the vertex from, or graph a parabola from vertex form.